I feel honored to be the closing speaker here. I wasn't originally scheduled, but we shifted around. I don't think I've ever been a closing speaker at an event. Sometimes I've been first. So this is really fun. I'm going to try to keep within my allocated time, although somebody in my company pointed out I have no time limit because, there's no one pushing me off stage. But okay, so I think this topic for me is one I'm very passionate about. I sometimes do give topics, talks that are a lot more AI focused, really a lot about like what crypto does for AI, what AI does for crypto. It's incredibly great. I think you can hear a lot of things, but I think when we talk about it at Eigen, I think it's an interesting angle. So I invite people to look at that. This conversation, though, I'm not going to mention AI once, which is a little refreshing these days in crypto. I'm going to talk about crypto settlement and manifesto for open source builders. Can I ask everybody to raise their hands? Everyone, please. Please, please, please. Okay, good. Okay, almost everybody. And then I'm going to ask you to drop your hands if you are not in the Web3 space. I am, but okay. All right, good. Okay, so we've got a number of people here who are kind of bridging over. And then a number who are in the crypto space. So I'm going to try to address both groups. The important reason why I do that is the manifesto for open source builders. I don't really have to go into the details of crypto as much, but I have a little description here. It's still pretty brief intro, so I think it's a good way to kind of look holistically at what crypto does as a net value add without getting into proof of work, space-time, stake, all of that kind of gobbledygook. Then the more important part for people outside of crypto is verifiable clouds. They're verifiable because they use crypto settlement, but normally if I wanted to, I could just kind of simplify crypto settlement even more. That's the bulk of the talk. And then there's a couple of wrap-up slides at the end, which are just explaining what the implication is for this. And I'll talk about two angles. One is the people who build open source, and open source itself gets much better regenerative funding in this model. And then why web consumers win. And a lot of times people talk about consumers with crypto about identity, better privacy, better data control, all of those kind of things. Those are all there too, but I'm actually going to present a different reason. So just quickly saying about crypto and blockchain, there's really only three key things that blockchains do that are so critical at the technology level. One is they permissionlessly allow anyone to run the software and to essentially have all the state, meaning that you got the open source and the open data to be able to verifiably just say, hey, I'm going to just keep going. They have liveness, meaning that it's essentially impossible to stop the blockchain from running. That's very important. A lot of times you have nation states as well as other actors that try to attack protocols. You can't send them a cease and desist. They just exist and won't stop running. And then security. Security is the one I'm going to talk about most. So I'm just want to kind of say accurately what does that mean. And it means that you will not actually revert transactions or like commitments that have been written to the chain. And so it's sort of like immutability. So there's three aspects to the security or the settlement: financial, tech, and social. And they all are important. Financial is the granddaddy of like Bitcoin and others. You have assets to move around. Tech is going to be a big part of this talk, meaning in verifiable clouds, you have a lot of things that you're doing: computation, data manipulation, in communicating data. And you want to make sure everything is done very accurately without just trusting somebody who says, oh, it was done correctly, the data's right, the computation's right. And then social, which is very important in blockchain. If we did not have the social aspect, we could still have, even with blockchain systems, people kind of centrally saying, hey, there's a group of people who own the protocol in sense of tokens and others. They could start being monopolistic behavior as well. So crypto has this idea of forking. We've seen this on all of the crypto protocols. There's always a threat. The community says this isn't working for me anymore. The data is open. The running the chains are open. And so you just actually create a new chain. Like, a lot of people at this week at SF Blockchain Week are talking about Ethereum or ETH. And ETH is not actually the original Ethereum chain. The original Ethereum chain had ETC, which was kind of a copy of BTC. And that was forked because of a problem that happened on that chain. So the examples of these, financial settlement, if you're in Web3, you recognize all of these. If you're not, then it's not useful for me to go through it as much. So I'll just kind of skip, but they're assets, a verifiable cloud, and then social, I refer to it as the ultimate backstop to central capture. If you have that, then you can prevent yourself from ever getting to a point where protocols are going to be destructive for the users and society. So it's extremely powerful. So now getting to the part of like, where does software actually run? For a long time, we've had it running on this tech stack, which starts at the very bottom with real infrastructure. And then as you move up, you get to the point where you're instead running OS, virtualization, middleware software, runtime, the data, the application. And that tech stack, originally, while it was all sort of managed by the people who made the software, over time, it got replaced with these three concepts: the infrastructure becoming a service through software APIs. So that's things like virtualization and storage generalization like Amazon S3 if you're a developer, platform as a service, and then software as a service. And so in crypto, infrastructure as a service has a new name: decentralized physical infrastructure. Platform as a service has always remained middleware. And then software as a service is a lot of the end user apps. So when I talk about verifiability and crypto settlement, I'm just going to say there are chains that just do it by everybody running every transaction. Very inefficient, but that is actually how the original Bitcoin Ethereum worked. And then the improvement on that are these moon math zero knowledge proofs, where you can take an infinite amount. You can have weeks and gigawatts of power running a computation. And at the very end, it produces a very succinct little under megabyte proof. You essentially check the proof, and in 10 milliseconds that weeks of thousands of computers running did exactly the right thing. It even checks for hardware errors, so it's not even unscrupulous players. There's a more optimized, cost-effective version of that, which is a fraud proof, and I won't go into it, and then trusted execution environments. EigenLayer, we're kind of talking about specifically two types of cryptoeconomic security. One is those attached to on-chain verifiable cloud operations or hardware software operations. And then this other one, which is the social settlement layer, which is humans deciding something was done correctly. It's a very powerful concept. Like, you can actually commit as a company, if you're a rideshare, for instance, that you will never take more than 5% of the fee of the ride, which is very different. Like, you look at something like Uber, it started at 20% take rates, moved up to 25, 30, 40. I was recently in Denver at a crypto conference, ETH Denver, and Lyft showed how much money went to the driver. I was paying for $12, $14 rides. The driver was getting $3.50, which to me was shocking, right? 70, 75% type take rates. So things like this, I mean, the idea that actually crypto, you can't do it with on-chain verifiability because you can always change the software, change the fees. But off-chain, crypto now allows through a new primitive, which is a whole nother talk, or talk with me if you want to learn how. You can have slashing of somebody's committed value based on a human parsable statement that they made, and then users socially saying, wait, you violated that. Another great example, there's so many more that I think people are going to come up with, but imagine a social network. We have decentralized social networks, but they don't have off-chain commitments about their privacy policies and how they're going to monetize users' attention. But you could have a policy like, if we're going to add a new monetization of users, it has to be approved by the users. If we're going to, decrease the privacy of what you're doing and release it to more people, we actually have to get your approval. If we don't, then users will see and say, hey, this company has billions of dollars that's slashable. So we slash it, and the data is public, and the protocol is public. So we then go ahead and run it somewhere else. So guess what happens then? A company will not actually do these bad actions because they would lose a lot for it. So, so we have these words here, autonomous and verifiable. You're going to see there's a cloud version of that, which I've been talking about what software actually runs on, the cloud. The service is that whole software as a service, platform as a service idea. And I said I wouldn't do AI, but I should actually say AI or AGI agents can also be inserted under services. Autonomous means that the software is unstoppable. It has its own ability to just keep running. And verifiable means that when the software runs, the results of it are, have a cryptoeconomic type guarantee that what it's doing is what was committed to, either through the open source software or verifiable to English type constitution commitments of companies. So, the AVSs like services, they actually were created by our protocol. Anybody can create them. There are other protocols that are competing with us now. They're all over the place, which is great. And they all together can create this autonomous, verified, unstoppable, trustworthy cloud. And as I said, permissionless means it's autonomous and censorless. And then verifiable means that the underlying thing why there's a trust in cryptoeconomic protocols is because somebody has put up the trustless thing, which is actual monetary value. And if they violate conditions, that monetary value is removed. I mean, just imagine, if you actually could have companies or bad actors not just having corporate social responsibility, but in fact, having a commitment that when they do have something bad happen, they lose a whole lot of money. So it changes very much rational actor behavior. So, in terms of when I'm talking about the cloud, there's a lot of things that you could be doing with this. These are examples of kind of software that you need to be running cloud databases, Linux. You need watchtowers to make sure that software is running correctly. Proofs that are not available right now to software but are available through this framework are proof of location that you're actually running in other countries. You'd be surprised at how hard that is to actually tell. But it is actually a solvable problem. Really smart computer scientists have figured it out. These are names of companies that are actually providing these proof of identity of actually being a human. It's actually also possible to, and quite valuable to prove that something is run by a machine and not some mechanical Turk. You might actually want to do this for a lot of reasons. I can imagine one, you might want to prove that this isn't like slave labor that is doing these things. It is in fact like an AI. So a lot of good things, are being constructed there. So why are open source builders winning in this framework? They are winning because when we think about proprietary moving to open standards, stepping back, this is a historical slide. Won't go through it, but if you look at my slides, I at the end show my Twitter handle where these are going to be posted. Networking moved open, internet was open over time, software moved to open source software, private data centers went to something more open, public clouds, but still proprietary on their APIs and value capture. And then post-blockchain, I don't think we've hit the tipping points for any of these yet. These are all Robert Drost estimate of tipping points. I'm not pulling from data. There's no references here. But I think a lot of things like walled garden identity that we don't own, tipping point hasn't happened. Same with data, public clouds. So there's incredible amount of kind of capture and monopolization and therefore control and bad policies that happen in the current public cloud. We have almost, I think those add up to 56, almost 70% in 3 companies. And this list here is approaching the mid 80s, very small number. And the amounts of revenue are massive. People don't really track it, but we're in the trillions of dollars. Oh, really? Okay, so let me then go to this. Sorry, I got the 5-minute warning. I do want to keep it to here and let people get going. Evolving open source software in relation to how it runs on hardware. I'm bookending the entire history of open source software, moving to blockchain now. In both of these, you have sort of hardware at a layer moving from private to now these things I was talking about, decentralized physical infrastructure. Open core software, that's the crux of why it is digital commons and digital open source software. That's the model where you develop and build software because you love to do it, you're a hacker. Then eventually people use it, you need money, you build a company around it, you take a little bit of money for it, and you keep developing the open source core, that digital software commons. That was the pre-cloud open source vision. We started getting billion-dollar open core companies in the early 2000s. But then something happened. The Web2 public cloud went from being something really helpful to run open source software that open source creators used, putting value back into the open source core. A new fork was created. Web2 Cloud started creating their use of open source cloud, where they took the software, wrapped it in a small interface, and then took the value and charged money for it. I show the line of value going back. It is trivial compared to like what open source founding teams actually put back in. And the amount of value that's extracted is not even proportional. I have to make that arrow bigger because they take a lot more value out because they are competing with the open source developers themselves. That relationship bookended flips back to the pre-cloud open source version. We still have the cloud available for open source developers to put out their software to, be able to scale elastically, everything that you want in the public cloud. But there's not a single public cloud company at the base that's wrapping up all the APIs. These are now protocols, decentralized protocols for databases, for compute, for storage, for the massive numbers of different software as a service. And so you don't have a central person who's going to monopolize and take value. And there's no one person who's going to build an open source version of yours. If it is, it's a competitor, which is another group of open source developers. It's not a company that has hundreds of billions of dollars of revenue to compete against the poor open source developers. So that forked value capture is now basically crypto monetized open source in the Web3 world. And it really regenerates that money back into the open source ecosystem. So a lot of a conference like this on Funding the Commons is going to talk about community contribution, donations, sort of grant making. And I love that. I think open source should be funded in many different ways. This is talking about a systemic, profit-driven, regular capitalism way that we get much better open source and much better outcomes for open source developers. So it's very exciting to me. And that's why it actually is my big mission for why I'm in crypto. I have never been here for the decentralized token value in the finance sense. So I do want to point out, this is a really big thing. This is a single screen developer cheat sheet. This is a small subset of the APIs and software that you can get on Google. And I would probably have to go through one by one in order to say a percentage. An appreciable, and I think majority, and maybe actually most of these software packages are renamed, packaged open source, open core software. And when you go on the website and look at it, this goes on and on and on. So all of those are actually kind of value extraction from open source. Okay, so now, what I want to say is like, why is this better building this way? I actually argue it's better for fundraising. If you look at how quickly the velocity for investors on getting returns in the spaces, in a year and a half, you get a couple up rounds. You already released to the public markets. In crypto, it's called an initial coin offering versus an initial public offering. It's done decentralized around the world in one instant. You have a lot of build up before the time, great ability to kind of market and reward your entire consumer base. You have your users ready to go. So I actually think in the end, this is better for investors. This is going to be the faster action for money going in and then cycling the money for future startups in the decentralized space. Better for building, you de-risk and you're not competing against the actual platform you're deploying software on. You also have the ability that you have global versus walled gardens of things like data and identity. So you actually start off new protocols without having them empty. You have a network effect in Web3 to base your protocol on. Second to last slide. And then better for outcomes, more ways to monetize. You have actually the full freedom of tokens. And the crypto economy is much more flexible than the capitalism construct. It's a great coordination mechanism, but it was created 400 or 500 years ago. And so it's kind of crazy that we're still using it exactly in that form. In a sense, crypto is sort of creating a much better version of capitalism, much more freedom and innovation can happen. Web2 consumers, this is the point I wanted to say that, the consumer superpowers, of course, people focus on the data and other things, and those are really important. You bring all of your data with you. If you're an Uber driver, you go to any new thing like the example in Southeast Asia of somebody creating Uber with a 5% take rate, 0 to 5%. You can now actually take all your reputation assets from Uber and Lyft and any other rideshare service you are, and you can import them into new crypto protocols. And that is something dramatically new. So drivers can trust riders, riders can trust drivers. Very different. And you actually get choice. This one, permissionless algorithms, it's a little bit esoteric, but I actually think given that your information diet or your attention is a really precious asset, you are you think what you consume in a lot of ways. And so imagine a world where what you're looking at in YouTube or social networks or others, you choose. Maybe you actually just put it as an LLM, or maybe you have your favorite influence, spiritual coach, whatever, and they give you a moderation algorithm that you choose. And you may choose a different moderation algorithm to start the morning, and a different one to wind down at night, and a different one when you're hanging out with your friends. So, we should have open, exposed, choosable algorithms for what we're actually consuming on these platforms. The final one is that there's a reason why capitalism has been the dominant mechanism, and it encourages competition and a lot of alternatives and kind of a meritocracy. It eventually collapses to monopolies in a lot of places at scale, but the beginning part is really good. So by having these types of open, fast innovation, we actually see for users new features and improvements with higher velocity. Monopolized economies stop creating new features because they actually don't want change. They want to protect. If there's a good new thing coming up, who remembers how many times Facebook has bought things, right? They bought WhatsApp, they bought Instagram. They do that because, they actually do not want to compete against these people. If they need something, they buy it, and then they kind of freeze it for the most part, unless they have to, like with Snapchat, add, ephemeral images and messages, things like that. So the takeaway message on that one, very, very simple message. With competition, you innovate. With monopolies, you stagnate. And I think that's the final concept there. I actually have a list of this. So if you grab the slides, these are my information diet of some of the things that have led me to this thinking as I've gone in the crypto space. A lot of great ideas. If you're not familiar with them, take a screenshot, go read about them. The majority you can either read open, like Carl Fogel's book. He started writing in the early 2000s. Fully common, good funded. Every single version now, you can download the PDF, you can download or read it on HTML. You can also go ahead and you can buy a very inexpensive printed copy if you're down for that. Okay. And so takeaways, we got those takeaways. Okay, you can read more of my thinking on this. There's a full-length article about this in magazine ETH Investor Club, which does periodical every 6 months or so. Great articles from Kevin Owocki in that issue as well, who was talking here, as well as Tim Bako, who is one of the defining people in the Ethereum Foundation. And then also, if you want to read more about what autonomous verifiable means, there's a great blog article that really smart guy in our team wrote. And then if you want to capture my Twitter, I talk about stuff like this a decent amount. And you can look at this and other slide presentations. I drop videos of things that I do and panels there as well. And then if you actually want to talk with us in our protocol, we currently have about 40 live SaaS and PaaS protocols that are building and deployed. So they're actually accessible for developers. There's, we're passing 200 that are in the pipeline of people who are deploying soon. And if you look at the open source world, I really think that number goes up into the thousands. I will also say, we are not a very extractive protocol. The only thing that we do is we allow the decentralized trust security commitments to be made. We actually don't compete in any of these markets in the cloud. It is fully meant to be built by open source developers. And, like I said, if somebody thinks we're doing the wrong thing and we're being too competitive to our own space, they can fork us. Okay, so that's it. Thank you all very much for your attention. Done? No questions, right? Or are we doing any? If anybody has a question that they think would be kind of useful to share for the whole audience, feel free. Also totally fine. We're getting to the end of the day. So, but I'll just give a moment. Sometimes people do think a little bit. Oh, sorry, you were by the light. I couldn't see you. Yep, all the way in the back. Can you do me a favor, just so I know? Can you say your name and, where you're coming into this conference from? I can repeat it for you. Okay, that's great.
It's really good. Al Morris, Coin Network. We're also a computing protocol similar to Eigenlayer. What do you think of... There does seem to be an issue in this industry with shelling kind of effects around things. So in the same way that like Bitcoin kind of moved over to Ethereum for wrapped Bitcoin, do you worry at all about the effects of monopolization, actually? Like we're probably going to end up in a duopoly of compute networks at some point, at best. Or a monopoly, actually. It should head that way eventually.
Yeah, I mean, this is one thing that, even when it comes to monetary systems, I sometimes worry about crypto in general because, if you're ever read Debt the First 5,000 Years, they have a great observation there that on average, a money system in a society has had an average lifespan, average or median, I don't remember, of 80 years. So we see a few random examples like the Roman Empire or, British Empire or now American Empire. And you see currencies and monetary systems that last hundreds of years, albeit with, different levels of inflation. But most actually eventually hyperinflate or the government's overthrown or, you even have things like in India where they just basically turn off an entire cash system and then move to a new cash currency. So it's both very exciting to have to have a money system that's meant to last forever. But it also sort of points out there could be problems. As far as duopolies, I think the moneyness aspect is probably the place where there's some kind of feeling on risk on the blockchains. I think for stuff that's running on a blockchain, you're very able to kind of mute over and run other places. So at least for Ethereum, like the EVM has propagated itself off into the Cosmos ecosystem. In Solana, they have an EVM compatibility layer in Avalanche. So there's many kind of options, even if they're not using the original protocol. And again, I kind of fall back to on the social settlement side. It may be harder for societies to take like multi-trillion-dollar monetary assets and fork them, although in reality, their data and everything is around to do that. But definitely when you're looking at like layer one protocols or others, the history of seeing L1 forked on Bitcoin, on Ethereum, we've even seen on Ethereum, there was one time a protocol that launched, very bad founder. He did a few bad things and the community just, created a forked protocol and took away all of his tokens. That's a powerful thing. So the construct of the social settlement on Eigenlayer, the new cryptoeconomic primitive, anybody can use it, allows you to not have to go through the painful L1 forking where the slashing kind of takes potentially months, or like the ETC ETH fork took well over a year and a half to settle what was the valid chain that everybody was going to work on. But this new cryptoeconomic primitive allows you in about 2 weeks, maybe maximum 3, that the slashing and the canonical fork is decided. And, so that actually speeds things up. Sorry, I kind of riffed a lot on it. Did that cover the duopolies, or is there still...
Yeah, pretty good answer, I think. At least I see where you're headed. One other small question, which would be around the collateralization of workloads, especially in like compute networks. Do you see that as a limiting factor, or is there some advantage, silver lining kind of thing that we're missing?
Did you say collateralization or the what?
Collateralization for compute workloads. So if you have to stake for every compute workload, that basically doubles the collateral required for the system to operate properly.
That's a great question. So the reason why, just for people who aren't familiar with why collateralization can cause an issue, is because for somebody like in the non-crypto regular world, they kind of get collateral for free, and they get it at scale when they're like kind of ready for monopoly and network capture. Just taking, I don't mean to constantly be a punching bag on, turn AWS into punching bag, but it is the biggest. So let me just talk about it in that sense. So, people kind of trust that there's great SLAs around data, around privacy, and around performance. And they are many, many times violated. Like we've had long outages, and there's not actually compensation made, and there's a reputation hit, but there's not really a lot of things to do if you're already built on Amazon. So collateralizing is powerful in crypto because now, like in Filecoin, our Filecoin Foundation's great sponsor of funding the Commons, and Juan Benet created this whole conference, I think, originally. So that's great because now you know the SLA is backed with real losses for somebody who doesn't do it. And we know that's a lot more incentivizing to any business entrepreneur. The challenge is that like assets, if you have a asset like US dollars, right now, the zero risk kind of return in T-bills or T-bonds is like whatever, 4 or 5%. And so you would expect then that people would say collateralizing and putting $1 million down behind your storage commitments is also costing you $50,000 a year, and maybe higher because if you're doing it in a crypto token and it's volatile, maybe you need 10%. So there's an aspect of our protocol which has actually now proliferated. It's a DeFi category called restaking. In restaking, you use the same capital asset. You don't rehypothecate. It's not like something called liquid staking where you issue a new version of the same token. But the key thing that you do in crypto for the slashing, where somebody does something wrong, and then once you prove they've done it wrong, you essentially take their assets away, typically burn it, but you can also redistribute it to damaged parties. And we allow you to put kind of stacked multiple slashing conditions on the same collateral. And so, of course, you have to be careful. There's some information theoretic stuff you have to do so that you don't get into kind of spirals. So you want to spread it out. And there's also kind of reuse of some of the slashing can be put back in to keep coverage for other things. But, it is actually, it's not that hard. Like that is tractable. And so then you can actually have assets that instead of having one slashing condition and therefore having to have like a 10% return on one protocol, if you have 10 or 20 different uses of that same capital for collateral, then, simple math is just divided. So, 10% divided by 20 says now you're covering 0.5%. And so 0.5% is much better on $1 million of collateral. That's $5,000 a year. And so that's no longer your major cost of goods. So this capital efficiency, in my opinion, is really necessary to kind of combat the monopolization of a reputation-based non-cost capital in the regular Web2 world. Short questions, long answers. I'm not doing this well. Okay, we're going to take a new question, then we'll come back. Okay, thank you. Oh, no, we're out of time? Okay, just come up and talk to me afterwards. Thank you, though. Those are two great questions.